Good morning, student. Let's start today's class. Okay. Today we will study about the flow control. In previously we have seen that in uh, OSI model or in TCP IP model there is a function which will happen. There is a function that is called control of speed or flow control. That flow control will describe here what is or how we control the flow of data uh, by using any techniques we describe here today. Okay, or we briefly discuss about that flow control. Okay, it is the mechanics that ensure the rate at which a sender is transmitting is in proportion with the receiver capability. That means the flow control ensure that or maintain that the speed at which the receiver sending the data the or the speed at which the receiver sending the data is same as the speed at which sorry the sorry the speed at which the sender sending data is similar to the speed at which the receiver receive the data. Okay, otherwise what happened if the speed of receiver or the speed of sending data is more than speed of the receiving data, then what happened, the some data will be lost. Okay, because the receiver receive the data very slow, or receiving capability is very slow. Okay, especially in case where the sending device can be send data much faster than the receiver can receive. This uh, this uh, this uh, flow control is needed, especially when the sender sending data is much faster than the receiver can receive the data. Okay, if the sending speed is more and more than the receiving speed, then this flow control is needed. Okay, flow control is management or management of data flow between computers or devices or between nodes in a network, so that the data can be handled at a efficient pace. Okay, then for modern connection, either X on or X off or CTS or RTS, which is CTS means clear to send or read to send, uh, commands can be used to control the data flow. That means uh, in practical way this data flow is controlled by programs. Okay, and in the programs these commands X on or X off or CTS or RTS, which is CTS means clear to send and RTS means uh, read to send. Okay, so these commands will used in the programs to control the flow, to control the data flow. Okay, there are two types of techniques of the flow control. Okay, one is stop and wait flow control, another one is sliding flow control. There are two types of data, and here you see how the data will flow in a frames. Okay, this is, let's say this is A sender, this is B sender. Okay, first request is happened. After requesting, the one frame is transferred to sender to a receiver. In the frame in previously we know that the frame is a consist of a block of data. Okay, or block of information, which information we want to send. That information formed a frame or transmit in a form of frame. Okay, and after arrival, then another request and another frame will sending. Okay, and here arrival at receiver end. Okay, this way the flow of frames will happen. Okay, or flow of data will happen. Now fast technique, let's see fast technique, which is stop and wait flow control. Okay, if data frame arrived at a receiver side faster than they can be processed, okay, the frame must be stored until their use. Okay, here what happened, if the data arrive at the receiver end faster than the receiving data processing power, okay, then what happened, that data will stored until their use come. Okay, or their turn come. Okay, that means in a queue. Okay, in similar way, in the receiver end there is a queue. Okay, in that queue so many frames are there. Okay, one after one, because since the processing power of the receiver is slow, then one after one frame processed, but and the rest frame which will arrived earlier, they should be wait. Okay, or they they must wait. Okay, then the sender has to wait for an acknowledgement for every frame to be sent. That means here what happened, one frame is transmitted, after one frame is transmitted, one acknowledgement signal will be sent from this receiver end to sender end. And the sender, after getting that acknowledgement, they send another frame to the receiver end. Okay, this acknowledgement, what acknowledgement means, uh, sending the information that that the receiver received the sending frame which will previously sent by sender. Okay, that means one data, let's say one information sent by sender to receiver. Okay, but where how can the sender can get how can the sender know that that information delivered uh, get delivered in the receiver end? That acknowledgement instruction um, give the information that that frame which we will send, which we want which we send is delivered at the receiver end. Okay, and hence the next frame is sent only after acknowledgement is received. This process continues until the sender transmit an end of the transmission EOT frame. Okay, that means after completion of all the frames. Okay, then the last frame or last instruction sent by sender is that uh, end of transmission EOT. Okay, frame. Okay, then the receiver indicates its readiness to receive data from each frame. Okay, for each frame sent, there must be an acknowledgement which takes a similar amount of propagation time to get back to the sender. That means the the same amount of time which takes by acknowledgement, or the the amount of time which taken by the frame to transmit from sender to receiver, okay, the same amount of time will take by the acknowledgement from transmit to receiver and to sender end, okay. However, only one frame can be transmitted in a time, okay. In same time only one frame will be transmitted, okay. This lead to an to inefficient if propagation delay is much longer than the transmission. This is the disadvantage of that method. That means it can only transmit one frame at a time, okay. Here you see, first this is A, this is sender, this is receiver, okay. First frame 0 is transmitted, okay. After frame 0 transmitted, one acknowledgement frame are there which will sent by the receiver to the sender, okay. After receiving the acknowledgement, the receiver the sender again send frame 1, okay. Frame 0 is already sent and now frame 1 will be sending, okay. And after that an acknowledgement and so on, one frame and acknowledgement, frame acknowledgement, frame acknowledgement. This is the process of our this technique, okay. Now let us see the second technique, which is sliding flow control, okay. Sliding flow control, it works by having the center and the line wise the receiver. It works by having the sender and likewise the receiver have a window of frame. There is one window in the sender and the receiver end, okay. And each frame has to be numbered in relation to the sliding window, okay. That means that sliding window, the each frame are numbered, okay. The sender can send as many frame as would be fit into the window. That means in previous technique we only send one frame at a time, okay. But here we send at a time as many as frame that the window can take, okay. If the window can take 7 frames, then we can send 7 frame at a time. This is the advantages of this type of control, flow control, okay. And then the receiver, when receiving enough frame, will respond with an acknowledgement of all the frame up to a certain point in the window. That means if you send 7 frame, okay, but the receiver can receive only 4 frame at that time, okay. After receiving the 4 frame, or the capacity of the receiver is to receive 4 frame at a time, okay. Then after receiving 4 frame, he send a acknowledgement to the sender, okay. Then sender again send one window, okay, of 7 frame to the receiver, okay. This is the process, okay. This window can hold frame at either end, okay. When the receiver send an acknowledgement, it include the number of next frame it expected to receive, okay. That means when the window when the receiver when the receiver send an acknowledgement, it include the number of next frame it expected to receive, okay. If the window size is sufficiently large, the sender can continuously transmit packets, okay. Now let's see what happened in that process, okay. Here you see, this is source, okay, this is destination, or this is sender, this is receiver, okay. Here one data this is our data. Okay, this is our data we want to send. Okay, this much of data. This is one frame. Okay, and this big one have is window. Okay, and this window, let's say we have an window that have 7 bit, 0 1 2 3 4 5 6. Okay, or 7 frame. So we have a window that window can transmit 7 bit at a time. Okay, but but what happened, but the receiver can only receive 3 frame, okay, at a time. So first three frame f0, f1, f2, that means f0, f1, f2 transmitted to the receiver end. Okay, then after after received by receiver, that 3 frame, then one acknowledgement is given to the sender. Okay, that the and this acknowledgement, you see why this is ACK acknowledgement. ACK means acknowledgement 3. That means the receiver want to receive now from the 3, or from the 3 frame. Okay, or then the number at from where the receiver want to receive the data. Okay, that is denoted by 3. Okay, because the 3 the frame next window start from 3 frame. Okay, so here what happened, after after receiving the 3 data, one acknowledgement there. Okay, so after and before that, before acknowledgement, after receiving the 3 data, rest 4 data are there. Okay, rest 4 data are there. So the window size reduced and in the 4, because the 3 data will be sent successfully. Okay, and the window size is reduced, and after getting the acknowledgement, the window size again 7, or again be 7, and you see this window slides 3 frame. Okay, so this is called sliding window uh, flow control. That means this window slides bit by bit or one by one until the frames are not entered, all the frames are not transmitted. Okay, so here what happened, in first step, this window, okay, uh, transmit 3 frames, then after it slides that 3 frame. Okay, slides right to the that 3 frame, and only after getting acknowledgement, these window can slide. Okay, here receiver end also the window is slided. Then after that again uh, after that again 4 4 frames transmitted. Okay, okay, then one acknowledgement is there, and here rest 3 frames are there. Okay, and again this frame slides. Okay, from 7 0 1 2 3 up to 7. Okay, here also this frame slides, and again data transmitted. Okay, that means here what happened, first transmitted 3 bit, and then the frame slided 3 bit, or 3 frames, sorry 3 frames, first transmitted 3 frames, and after acknowledgement that frame slided that 3 frames. or previously sent successfully 3 frames and again transmitted for 4 frames, sorry, 4 frames, and again the frame slided, that 4 plus 3 7 frame. Okay, thank you.